Like multiplication, quotients can be written symbolically in several ways. This includes the division symbol, a divided by b is c. That's the division sign notation, which is also called an obelus. A over b equals c, that's the fraction notation, or the a divided by b equals c in long division notation. In each notation, the a is called the dividend, the b is the divisor, and c is the quotient. And just as subtraction is defined to be as the inverse operation of addition, division can be defined as the inverse operation of multiplication. That is, 3 times 4 is 12, so 12 divided by 4 is 3. Any division problem can be reversed into a multiplication problem. Some ways that can be shown that we can use to show division include repeated subtraction, missing factor, and sharing equally. Repeated subtraction, earlier we had defined multiplication of whole numbers as repeated addition. Division can be defined as repeated subtraction. Students solve divisions by subtracting or crossing out equal-sized groups from the total in the visual model until there is nothing left. So, for example, if I want to show 21 divided by 7, 21 minus 7 is 14. I subtract 7 again, I get 7. Subtract 7 again, I get 0. And so I can do 3 subtractions. 21 divided by 7 is 3. Unlike with repeated addition, you may end up with a remainder, something left over, and we'll get to that later. So, as an example of repeated subtraction, Ms. Harker has 28 students in her class whom she wishes to divide into groups of cooperative learning groups of 4 students per group. So you start at 28 minus 4 gives you 24, minus 4 is 20, minus 4 is 16, minus 4 is 12, minus 4 is 8, minus 4 is 4, minus 4 is 0. So ultimately, I start with 28 students. I can subtract 4 7 different times. So there are 7 groups overall. 28 divided by 4 is 7. Yeah, so use repeated subtraction to find these quotients. Well, 8 minus 2 is 6, minus 2 is 4, minus 2 is 2, minus 2 is 0. And so 8 divided by 2, I can do, I have 4 different subtractions. So 8 divided by 2 is 4. 21 divided by 3. So the 21 minus 3 is 18, minus 3 is 15, minus 3 is 12, minus 3 is 9, minus 3 is 6, minus 3 is 3, and minus 3 is 0. So if I count, that is 1, 2, 3, 4, 5, 6, 7 subtractions. 21 divided by 3 is 7. Another way of modeling division is with missing factor. If you recall, one way of modeling a subtraction was a missing addend. This is similar. And missing factor is where you ask yourself, what do I need to multiply A by to get B? Or multiply B by to get A? So if you let A and B be whole numbers where B is not 0, the quotient of A and B is the whole number C such that A is equal to B times C. So, for example, 10 divided by 5 is 2. 10 over 5 is 2. 10 divided by what is 2? That's the same thing as saying, well, all these are saying 10 divided by what? Or what do I need to multiply by 2 to get the 10? Example, the missing factor. If I want to find 12 divided by 3, I can ask 12 is equal to 3 times what? Since 12 is equal to 3 times 4, we know 12 divided by 3 is 4. If a rectangle has an area of 32 square inches, and the width is 4 inches, then what is the length? So recall that area is length times width. So we're basically asking that 32 is equal to 4 times what? Well, I know 32 is 4 times 8, and so that tells me that 32 divided by 4 is equal to 8. The third model is sharing equally. The repeated subtraction is used to find how many sets of groups or groups of a specified size can be made from a given collection of objects. So sharing equally is used to find how large a set or group needs to be if a given collection of objects is to be split among a specified number of sets of or groups of equal size. So for example, when Miss Harker checked her supply cupboard, she discovered she only has 4 sets of the Cuisinart rods to use for 28 students. So how many students must she assign to each set of rods? Well, there are 28 students. Split them among the 4 sets. That would be 7 students per set. So suppose you have 78 number tiles. Describe how to illustrate 78 divided by 13 with the tiles using each of the 3 basic concepts: repeated subtraction, missing factor, sharing equally for division. Well, I'll just go over it as an example for each of these. For repeated subtraction, you can remove groups of 13 tiles each. Since 6 groups are formed, 78 divided by 13 is 6. For the missing factor, we can use the 78 tiles to form a rectangle with 13 rows. Since it turns out there are 6 columns in the rectangle, 78 divided by 13 would be 6. And then sharing equally would be partition the 78 tiles into 13 equal-sized parts. Since each part contains exactly 6 tiles, 78 divided by 13 is 6.